First of all, our company is almost 100 years old, and we have deep roots in refractory metals. Metals such as tungsten, molybdenum, tantalum, niobium, etc. Our name is probably best known in other industries which use sputtering targets, such as semiconductor and flat panel displays. We've been supplier to both of these industries for a couple of decades. We are a relatively newer player in the photovoltaic industry, but we're building on pretty strong legacy supplying sputtering targets to semiconductor and displays.
So in the PV industry then, what's your real involvement now? What's your expectations?
Sure, good question. So as I mentioned, our specialty are refractory metals, and not surprising, our biggest involvement on the photovoltaic side is the thin film part of it. CIGS or CIGS, as we all call it, and cadmium telluride are the two specific technologies which are using molybdenum. It is a metal of choice for a number of reasons, and we are primarily a supplier of molybdenum sputtering targets. I should also mention H.C. Starck is a company with broader portfolio than that. We also have various ceramic powders in our portfolio, and specifically silicon nitride powders is another material we supply for the needs of the industry for a completely different application. They are used in the growth of polycrystalline ingots as a liner for the crucibles. So these are our two ways we're involved. While molybdenum is our, I would say, workhorse, we are a big supplier to the industry right now. We also provide other materials. Sometimes they could be experimental materials for some next generation products. Sometimes they're just less widely used materials such as nickel vanadium or other sputtering materials used in thin film.
What differentiates you?
There are probably two things. One is what we have, specific technologies and machines we have. Another one is how we approach the market, how we do it. So on the first angle to that, what we have, well, we have a couple of technologies which are rather unique and special for the industry. We supply both, you can see here on the display, both planar and rotary targets. And the industry has been trending quite steadily towards rotary because they are more efficient, the cost of ownership is lower. Specifically for the rotary targets, we extrude them as opposed to sintering them piece by piece as other manufacturers do. And extrusion is a method which is known. What makes us special is we have perhaps the largest extrusion press, at least in North America, with over 5,000 tons of pressure. It allows us to extrude both at relatively high speed as well as, which translates to throughput, but also very large pieces. So our targets, no matter what the length is, can be supplied in a single piece monolithic tubes. That is a differentiator because in the end, I can talk about technical aspects of it, but in the end it translates into targets having higher power density, and our customers are able to realize higher throughput, which translates into lower cost. We source our raw materials directly from the miners. We start from the ore, and we convert the ore into metallic powder, and then we sinter the powder into solid form, and we machine it into a final target. What it means for us is primarily traceability. We know exactly what our raw material came from. We can ensure that the final target will be consistent, and what it means for the customer, we can ensure that there is consistent performance of the target from one batch to another, which in this industry is very important. You mentioned polysilicon going down and prices of silicon panels going down. Exact same thing is happening on the thin film side. I think on both sides of this industry, thin film and silicon, our customers are driving down that cost curve as hard as they can. That is the condition of survival. So you may not like it, but that is what the entire industry has to do to survive and thrive and grow. As far as impact for us, we are prepared to compete in this environment. We know we could be cost competitive, but also, I guess the critical distinction is what really matters for our customers is the cost of ownership, because in the end, their panels are valued at dollars per watt or dollars per kilowatt hour they produce. And when they calculate their economics, we want them to think about dollars or cents, whatever the case may be, per wafer or per panel or per watt, which in the end our targets contributes. So as we work with our customers, we try to ensure not just the lowest cost per target, but also the highest throughput, the highest power density, the lowest, the highest uniformity or the longest target life. All of these things in the end translate into lower cost per layer, which is the critical metrics we are trying to ensure.
Where do you really see growth coming from, for you in the thin film sector?
Yeah, well, we have two primary segments we're addressing. And cadmium telluride is a relatively well-established technology. I am a believer that they will maintain their cost leadership, at least for the time being. As fast as crystalline silicon has come down in price, still cadmium telluride is the lowest cost technology, and I think they carved out a good niche for that part of the industry, and I think will continue to grow in the applications. I think in this case mostly enterprise level installations, not on rooftops. CIGS is a different story. We see a lot of growth in CIGS off a very small base. It's a young industry. It still needs to prove itself. For me, I would say we are cautiously optimistic that CIGS will grow, that they will win and carve out their own niche in this industry. The key there is efficiency and cost, and the combination thereof, which is really the key metrics. As I'm sure you well know, in crystalline silicon, there's a very small gap between the lab efficiency and what is achieved in production. But in CIGS, it's still a large gap. It's almost 50% on a relative basis. And of course, all the CIGS producers are well aware that that's probably the biggest bang for the buck. As they shrink that gap, as they get towards higher teens, up there towards 20% type of performance, if they achieve it on a scale, that's where CIGS can really prove itself, because there are some good advantages to thin film systems, but they need to drive that efficiency up. This is partially where we see our role. Okay, we're a small part of the stack, but we will do what we can to help them drive that efficiency up, and if it can be done at competitive cost, that's how CIGS will deserve its place in this kind of ecosystem.
Obviously, a core part of any company involved in this specific area is strong R&D. Can you give us an update? What are your R&D efforts right now?
Yeah. So in this regard, our work in photovoltaic is similar to the work we've done, like I mentioned, maybe for 15-20 years on the flat panel display side and on semiconductor side. There's really two things we can do. We can either try to improve the target design, or we can try to improve the target material. For the design part, we can either work with the customer, or we can work with the tool OEM. And design really translates into either longer target life, or higher target power density, which means higher throughput, or better film uniformity. We have to improve some characteristics of the film or economics of the film, and part of it can be done through design. We're doing some of this work today, and we can squeeze this incremental efficiency out of the system, or out of the process by that. The other part is trickier. The other part is material. Today, majority of molybdenum supplied to the industry is nearly the same grade. It is a standard grade. That's what customers are using today at the earliest stages. In our observation, over time, specific proprietary technologies begin to be developed. They can revolve around material purity, just going to a different purity grade. They can revolve around composition, some type of doping or alloying if it delivers performance. Or it could be a specific engineered grain structure or grain texture. We've done a lot of this work in semiconductor industry, and we understand that grain size and grain orientation, they really matter. They do determine the sputtering characteristics. And in this case, we, again, either work with our customers or we work with third-party R&D institutions to develop this next generation materials. That's the two areas where we put our R&D dollars.